This is an AS Pure question on circles and in particular tangent and chord properties. The circle C has centre A with coordinates 7, 5. The line L with equation y is equal to 2x plus 1 is the tangent to C at the point P as shown in figure 3. Part A, show that an equation of the line PA is 2y plus x is equal to 17. Okay, so let's put this information on a diagram. So L, its equation is y is equal to 2x plus 1. I need to find the equation of the line PA. Okay, so let's draw that on. So that's going to look like this, going through the center of the circle, like this. And what we know is that when we have the radius of the circle, that's what PA is, and a tangent at that point, which is at P, they meet at right angles. They're perpendicular to one another. So the first thing we're going to do is to start by finding the gradient of this perpendicular line. So we know that the gradient of L, very easy to find, is just equal to 2. So sort that word of out. And so the gradient of PA, the line that goes through PA, is going to be perpendicular to this, is going to be the negative reciprocal of 2. So gradient of PA, or line PA, is equal to the negative reciprocal of 2, so that's going to be negative 1/2. So now we have the gradient of the line PA, but we know that the line goes through the point here, which is the center of the circle, and we know its coordinates. So since we know that the line PA, also we can put since PA goes through the center of the circle, center of circle, that means that we can write down the equation of its line using y minus y1. Okay, that's going to be 5, is equal to m, so that's negative 1/2, x minus x1, and that's going to be 7. Now we need to get it into this form here, so I guess let's start by multiplying both sides by 2 to get rid of this half here. So we'll have 2y minus 10 is equal to negative x minus 7. We want to bring the x to the other side. Before we do that, let's expand the bracket. So we'll have 2y minus 10 is equal to minus x plus 7. So we'll take away, or we'll add x to both sides, and then what we will do is we will add 10 to both sides, so we get the result as they want as required. Moving on, part B, find an equation for C. So C is going to be the equation of the circle. Now to find the equation of a circle, we need two things. We need the center of the circle, which we have, which is 7, 5, but we also need what the radius of the circle is. Now the radius of the circle is going to be the distance between the center and this point P, where the lines L and PA intersect each other. Okay, because we know that's on the circumference, because a radius and a tangent meet at right angles, or perpendicular to each other at this point here on the circumference. Right, so we need to find that point P first. So to find a point P, what we need to do is to take the equations of both our lines, y is equal to 2x plus 1, and the other line, so y is equal to 2x plus 1, and our 2y plus x is equal to 17, and we need to solve those simultaneously. So one way to do that would be just to take y in the second equation and replace it with 2x plus 1. We want to solve simultaneously. So we'll have 2, now y then becomes 2x plus 1 from the first equation, plus x is equal to 17. So expanding the brackets, we'll have 4x plus 2 plus x is equal to 17. So from there, what we'll have is 5x, if we put the x's together, and then if I take away 2 from both sides, 5x is equal to 15. That gives x is equal to 3. So now I have the x coordinate of this point P. So let's just do an arrow pointing towards it here. So what we've got so far is 3. And now we want to find the y coordinate. And the easiest way to do that is just to substitute this x into either one equation. I'm going to pick the first one, y equals 2x plus 1, it's easiest. So y is equal to 2 times 3 plus 1. So that gives me a y coordinate of 7. So 3, 7 is this point on the circumference. What I'm going to do now is to find the distance between A and P, the center and this point, and I use Pythagoras to do that. So what I'm doing is actually finding the length of PA. Let me use this modular symbol here to say we're going to find the length of that. So that's going to be the square root of, so let's start with the x coordinates, the difference between the x coordinates. So x coordinate at the center is 7, the x coordinate at the edge here is 3. So the difference between them is going to be 7 minus 3, which is going to be squared. So we're effectively doing 4 squared, plus the difference between the y coordinates. So we've got 5 at the center, and we have 7 at the edge. So that will be 5 minus 7 all squared. So that gives me the square root of 4 squared, which is 16. And negative 2 squared, which is 4. So I've got the square root of 20. So that gives me my radius of the circle equal to root 20. Leave it in exact form. And now we can find an equation for C now that we have the center as well. So this is going to be x minus 7 all squared plus y minus 5 all squared is equal to the radius squared, and the radius squared is going to be the square root of 20 squared, which is 20. So that gives me the equation of the circle. The line with equation y is equal to 2x plus k, where k is not equal to 1, is also a tangent to C. Part C, find the value of the constant k. Now, the first thing to note is that this tangent is parallel to the other tangent because they have the same gradient. So if I was to sketch that on my diagram, remember this is only a sketch and a poor sketch at that. So let's get this better. So it's going to look something like this. Okay, so don't take this literally about you know, exactly where it crosses the axis here, but we do know, and it's looking like the intercept of this tangent, if I continue this x-axis, y-axis here, is going to be negative. So I want to find where this parallel line to L crosses the y-axis, that's its intercept, and that will give me the value of k. Now, the other thing is that this other tangent passes through a point which is opposite to P on the other side of the circle, and I think we can probably work out what this coordinate is. Once we know what this coordinate is, we can use that to find k. So I'm just going to clear up this diagram a bit and take some of these things off here and just focus on this point P here. Yeah, we worked out that point, and that was the coordinate. Now I've got it here somewhere. Yes, 3, 7. So I'll just put that on 3, 7. I know the center of the circle here is 7, 5. So what I can do is if I work out the jump between the x and y coordinates between P and A, it's going to be the same jump from A to this point on the other side of the circle, which is what I'm interested in. So let's do that. Now the jump you can also call the displacement. So let's work out the displacement that takes us from P to A. So P to A. Now what happens with the x coordinates from P to A? Well, the x coordinate goes down by 4. It's going from 3 to 7. So the x coordinate goes down by 4. So I'm going to write this as a column vector. So -4. And then the y coordinate goes from 7 to 5. So that goes down by 2. I'm going to apply the same translation vector from A to work out what this point is here on this side. Let me call this point Q. So I'm now going to work out the point Q using this same displacement -4 -2. So I'm going to call this Q, this point here on the other side of the circle. Right, so from the center to this point is the same displacement. So 7, the x coordinate displaces by -4, so 7 minus 4, 3. And then the y coordinate displaces from 5, goes down by 2, and that will be 3. Right, let me just correct that. Sorry, I got this first displacement incorrect. So it goes from 3 to 7. Sorry, that goes up by 4, not down by 4. You're probably screaming at the screen wondering, what is Heinz Maths doing? Why is that wrong? Yeah, so 3 to 7, need to learn some basic maths. 3 plus 4 gets to 7. 7 minus 2 gets to 5. So 4 minus 2, right? So that will change what I have for my x coordinate, because 7 is going to get displaced by +4 to 11, right? So I was thinking 3 didn't seem right. I would expect the x coordinate to be bigger than what I had before 3. That didn't make any sense. That's why I went back and just checked, and I saw my mistake. So Q is 11, 3. Right, so we have this tangent which is parallel to L, so it has the same gradient, and we know it goes through 11, 3. So we can use that to work out K. Right, so it's y is equal to 2x plus K. Let's substitute in this coordinate 11, 3 and see what we get for K. So what y is 3 is equal to 2 times x, which is 11, plus K. So that will give me 3 is equal to 22 plus K. Take away 22 from both sides, and that gives K is equal to -19. So we found the value of the constant K. Let's write it a bit bigger here. K is equal to -19.